Okay. So we're going to go over primary trig ratios, which are known in short form as SOH. Okay. This is an acronym, and it stands to help us remember formulas. Okay. In other words, SO stands for the sine ratio. Sine theta, theta being an angle, is equal to O standing for opposite, divided by H, which is the hypotenuse. Do you know what the hypotenuse of a right angle triangle is? The hypotenuse of a right angle triangle. Yeah, it's always the longest side. It'll always be opposite of the 90-degree angle. So this will always be our hypotenuse. Okay, that will never change. CA stands for cosine theta, being equal to A standing for adjacent, divided by hypotenuse again. And then finally, tangent theta, which is the angle. So tan some angle is equal to O, which is opposite, divided by A, which is the adjacent. Okay. Now, the problem is our theta, so for instance, let's say this was theta, the angle we're working with, depending on our formula, is going to change everything. Okay. So, if we look at the first one, say this is theta for each of these. Okay. In the first case, I'm going to call these sides X and Y in each case. Okay? Hypotenuse will just be known as H. For sine, which will be our first guy, sine theta, we said is equal to the opposite. Well, the opposite of this angle is the Y. Okay? And divided by the hypotenuse, well, for our case, we're calling that H. So in this case, sine theta is Y divided by H. Okay? Well, what about cosine of that theta? Well, cosine of this theta is actually equal to the adjacent. Adjacent means to touch. So we're looking at the side touching the angle. Well, there's technically two sides touching the angle, but only one of them is not a hypotenuse. So we go with the one that's not a hypotenuse, which is X. Okay? So cosine theta, adjacent, well, the adjacent side is X, and the hypotenuse still is side H. Okay? And finally, tangent. Well, tangent theta, which is the angle, is equal to the opposite, which is our Y, divided by the adjacent. Okay? The adjacent, which is our X. So tangent is Y divided by X. So in the exact same triangle, when working with the exact same angle, we have three different ways to set up a formula to solve. It really depends on what pieces of information we have. That's how we decide whether we want to use sine, cosine, or tangent from the SOH. Okay, so for instance, I'm just going to make up theoretical numbers because technically in a triangle you have to be accurate, otherwise these numbers don't work. Okay, so I'm going to tell you that I'm looking for this angle here, and I have this information. Okay, I don't know this angle, so it'll be unknown, but I have the information of this, which is, I guess we'll give it a number, 5, and we'll call this 10. Okay, using this information, help me figure out which I need to use, sine, cosine, or tangent. So I'm looking for this angle. What pieces of the triangle do I have in reference to this angle?
10.
Okay, what side of the triangle is that?
The hypotenuse.
Okay, so we have the hypotenuse, and the 5 is what side in reference to this angle?
The opposite.
That's right, this is opposite of this angle, right? So in other words, which of the ratios deals with opposite and hypotenuse?
Thank you.
Let's see.
Thank you. Sine.
Sine, that's right. So we have sine theta, opposite being 5, and hypotenuse being 10. So you would use sine to solve that. Okay? Let's go down again. What if we were looking for, let's say, this triangle. And again, these only work with right angle triangles. That's very important actually for this. Okay? Very important that we know that only works with right angle triangles. What if I have this angle, 50 degrees, and I have this side, 6, and I'm looking for this, X. I have these pieces of information. Which of the ratios am I going to use? So we have this angle, and what sides of the triangle do we have?
The 50 degree and 6.
The 6 is what in reference to the 50 degrees? What side of the triangle? You have 3 options.
Adjacent.
Yeah, that's right. It's touching it. So this is our adjacent. And we're trying to find what?
Hypotenuse.
Hypotenuse. Right?
Yeah.
So, in which of the formulas do I use adjacent and hypotenuse? Yeah, CA. So we use cos, and instead of writing theta, we actually have the measurement of the angle, so we write 50, okay, is equal to adjacent, which is 6, over hypotenuse, which is x, okay? Now, in this one, we're isolating for x. Just to draw a reference back here we're looking for theta. Technically, to solve for theta, I gotta think of it like we have to move sine to the other side. In which case, theta is equal to, we have to use the inverse of sine to solve this. And we would use inverse sine 5 over 10, okay? That's called like the second function on your calculator, okay? You have something like that. So with that information, if you're ever looking for the angle, think that we're using the inverse of something. And if we're looking for a side, we don't. We're just trying to put that value into a calculator, okay? And finally, I have this angle, and I know that, or I'm looking for this angle. This is 6, this is 8. Which of the ratios am I going to use?
6 and 8. Can't you use Pythagorean theorem for that?
But I'm looking for the angle. I'm not looking for this side. So I'm looking for this angle here. Which of the ratios can we use? What are these sides in reference to this angle? This would be what?
Opposite.
Yep. And the other one?
Adjacent.
Adjacent. So what do we use with opposite and adjacent?
Tangent.
That's right. Tangent theta is equal to opposite over adjacent. And again, to solve for the angle, we technically have to make this tan inverse. Okay, because again, we're solving for an angle. When we're not solving for an angle, we don't have to do that. Okay, so that's kind of a crash course in setting up the TOA, where there are 3 angles there. Okay, does that kind of make sense? Oops.
Mm-hmm.